Today we're learning about Flask. Flask is a web framework written in Python. A web framework, also called a WSGI Web Services Gateway Interface in some IB materials, is a computer program that works with an HTTP server and provides dynamically generated web pages, aka HTML files, in response to web HT requests. Without a web framework, you'd have the old original static web. All web pages are complete .html files stored on a server. Ask for a page, get a page. Ask for a page 1,000 times, get the same page 1,000 times. For dynamic pages, that means that there is some Python functions that will create a new HTML page in response to each HTTP request. Flask is a tool that's designed to make this process easy. It will not seem easy, it will seem complicated, and Flask is complicated. Last week, I tried to level set for this process by looking briefly at the work involved in generating dynamic HTML by hand. Yes, working with Flask is complex, but learning how to use this complex tool is much easier than doing all of the Flask functions by hand. We're going to tackle this as two parts. First, we're going to read through and analyze the minimal Flask program. In computer science, we often call the smallest possible program in a language Hello World. These programs don't really do anything, just print the text Hello World to the screen. The minimal Hello World program in Python is print Hello World. The Flask version is slightly more complicated, and looking at it line by line will help us understand what Flask is doing. Then, we'll cover how to install Flask on your computer and actually run this web application. This is the official Flask documentation. Specifically, this is the Quick Start page, which explains the basics quickly. The goal is to provide just enough to get a project started and then get into trouble. The rest of this video will be me reading and explaining the very top of this page. If the video feels too slow for you, I encourage you to go and try to read the Quick Start page on your own. From Flask, import Flask. This line imports the class Flask, uppercase, from the Python library Flask, lowercase. But those are the same word. Yeah, they almost are. Python is case sensitive, so Flask and Flask are actually different strings. Also, there's a Python convention at work here. A convention is a programming practice agreed to and followed by humans working in a programming language, but not enforced by the language itself. It is a Python convention that classes should have a leading capital letter in their name, while the libraries are all in lowercase. Flask, little f, aka the Python library, has lots of different functions in it. We will use many of them later. But the core thing in the library is the class Flask. You can think of lowercase Flask as a huge collection of Lego. Capital F Flask is a specific box of Lego that builds the main core structure from this lowercase Flask kit. All of the other functions in lowercase Flask extend and build on the robot body of the big Flask. This line opens up the Flask library and brings out the big Flask box to use. App equals Flask, name. This line shows the Flask constructor, the function that instantiates the software object. That's a terrible phrase. Think of this as the line that actually builds the Lego robot from the Flask kit. This Lego box is pretty magical because you can build multiple robots out of the kit. You'll never run out of parts for these, although it's conceivable that you might run out of RAM on a particular computer if you build several thousand of them. Here's we've now built Thias Flask robot and named it app. After this, wherever you see us refer to app in our code, we're talking about this particular assembled Flask robot. What's with that weird name? Python has a bunch of internal variables, all of which are identified by the difficult to type double underscores. Hoskvarname mcord name is a flag that identifies how this particular Python file is being run. We'll see some more of that in a bit. For right now, think of codename as saying, this Flask robot we built in this Python program is named app. At app.route/. This is the whole of the law. It's obviously not the only line in the minimal Hello World program, but this is the only line where our app robot does the thing. This line is bookended by some strange symbols, so let's look at this from the inside out. / represents the root of a tree, or the root directory of a particular file system. Remember, HTTP and HTML emerged as a solution for HWO to share specific folders and files of particle accelerator data at CERN. So it was common to have an HTTP server set to share a whole complex tree of data. In a situation like that, slash would represent the topmost folder shared by the HTTP server. We have a format for how to specify these resources that you're familiar with. These uniform resource locators, or URLs, need to have computer port slash resource number. So that might look like IP address dotted port number slash path shared slash file.html. That would be a full TCP request. By the time this request has worked through the HTTP server and arrived to our Flask robot, the only part left is the resource path. For that, slash is the absolute most basic. If you don't have anything else to share as an HTTP server, you have something labeled //. But if slash is such a big deal, why is it wrapped up in string quotes like slash? Remember where this came from. This data came out of a HTTP request, which came out of a TCP packet. This slash was very recently not a cleanly printing character, but the binary data 00111111, aka 2F from the ASCII table. Somewhere down in that messy part, we try not to think about, there was some code that read a long sequence of binary and sliced it up into characters. We're safe here inside Python land and don't really need to deal with that. So when we're looking at the resource path, we can think of it as our friendly string friend slash. @app.route is a method, a Python function that's tied to a particular bundle of software that we're calling an object. You use methods all the time in CMU and in random.randint, or even with specific data, like mylist.sort. .route is tied to this particular software robot named app, which is built following the Flask instructions. .route implies that somewhere within the different files used in the library Flask, there is a section that says def route. Complex stuff here about talking to the HTTP server. This is a helpful abstraction for us. If you really want to know how this web framework stuff works, you can dig down and read through how .route does its job, but you don't have to. Instead, we can rely on .route being part of our robot app and know that it will probably work as advertised. Our app robot has a special .route superpower that allows it to talk to the HTTP world. Cool beans. This is what libraries do, what they are built for. Libraries provide tools to do complex tasks in a comparatively less complex fashion. Libraries are way to hide complexity. They are abstractions. But what's that email/DM @ doing there? The @ symbol is a Python operator called a decorator. Again, naming things is real hard. Don't give them too much grief for this. Decorators identify a chunk of Python code that should execute at a particular moment, rather than next in line as we read the code from top to bottom. Think back to CMU exercises where you worked with events like onMouseClick or key press. When you wrote code under onMouseClick, you were confident that the code would not execute unless the user clicked the mouse. How did we know the user clicked the mouse? Yeah, that was abstracted away from us, so we didn't really care. We just trusted it, and it basically seemed to work. @app.route is similar. The secretor says when app.route gets a HTTP request that matches the string inside route/resource/name, then and only then will the Flask app robot run the Python function directly below the line with the @decorator warned. Taken together, @app.route/ is a trigger, like the event triggers in CMU. It's also a bridge between the place where we're writing Python code and the topic 3 complexity of network interface cards, TCP packets, and HTTP requests. There's a ton of software between those 2 points, but the powerful part of Flask is that we, largely, don't need to care about them.